Wow, we all arrived within 3 seconds. 1, 2, 3. Hi guys. How are you all?
I'm good, thank you. How are you guys? How's the shoulder, Robert? Oh, you're muted.
It's getting better, slowly. Got to stay in the sling for another 5 weeks.
So what was the operation?
There were a couple things. They did some surgery on the inside of the shoulder joint, and then there's a tendon that kind of runs up over the top of your shoulders. So that was inflamed, so they cut it off and then reattached it to the bone lower.
Oh wow, gosh. Yeah, no, the miracles of modern medicine are just absolutely amazing.
I'd like to talk about that.
Right. Well, I guess I have a bias because I had a very annoying heart condition called tachycardia for all my life until I had a brief operation where they completely cured me. And my uncle lived for cancer. My sister didn't, but my uncle lived with cancer for nearly 30 years, and they kept him alive. So
yeah, actually, yeah, I was pondering this. I don't know what you guys want to talk about, but so I think the medical research is kind of like, the drunk trying to find his keys and looking under the stoplight or looking under the lamppost. Because, obviously that's the only place he can find him if you dropped him. But, eventually, they're smart and creative people, and they can kind of figure out what to do kind of by trying other stuff that didn't work. But the question I've been kind of asked to look at a little bit is, how would you think about opioid addiction?
So Payam actually suggested a topic for today, so I just wanted to bring that up. So should we split the meeting into 2 parts and cover both, perhaps?
Yeah,
Payam,
I'm totally fine winging it. Like anything comes up, that was just like something I came across.
I'd like to touch on it. Opioid addiction. Yeah. So Robert, I don't think you saw the article that Payam posted to us.
No, where was it?
It was on Slack.
It was on Slack.
Oh, sorry.
Well, why don't we post that for another week, Payam, so that Robert has a chance to read it? I read it, and I'd love to discuss it. I just think it would be more inclusive if Robert had a chance to take a look. So is that cool?
Sounds good to me.
What was the article about?
It's about this whole debate about AGI, artificial general intelligence, and what we should do to work towards it. And it related to all that discussion we had about the problem of induction and Hume and all that stuff. And I thought it was super insightful because there's some things there I hadn't thought of before. And it's a relatively short article. It's like a popular article. And it's written by this guy, David Deutsch, which is I really like, and I have his book. I was just gonna, like, if you want a new book to read, David, this is like a really good book. But we can discuss it. He's a physicist, he's not a computer scientist, but he has a very strange view that to solve AGI, we need new philosophy, not new computer science. So I thought that David would appreciate it, and I think there's a lot of interesting discussion.
Isn't that one of Paul Werbose's kind of go-to guys?
Oh, for sure, yeah. Although Paul, in reading the article, Deutsch is on the side that quantum computers are not good for general intelligence. So there is a discordance between Paul's idea around quantum AGI and Deutsch. I cannot participate in the argument because I understand the positions of neither. So.
Well, I'm not sure if he says that quantum computers are not useful, just that we have at least one case where quantum computation is irrelevant, which is being a human, being generally intelligent. So in that sense, you don't need it. But whether maybe you could be useful.
I agree that it's orthogonal to the question. So I'm not arguing with that point at all. But as I say, that these are two very different topics, and I just want us to be in a consensus. So Rob, we'll post that next week. Payam, I'd love to chat about it with you. If we have time later, we can touch on it.
Well, I could jump into it now too. I mean, I can try.
And the other thing is that Rob and I've been trying to write up a fake pseudo paper that I'd like to share with you, Payam, and see what you think. So there's quite a bit on
it. Why fake?
Because I've never written a paper before, but yeah, anyway, it's my attempt at a paper, haha.
Yeah, but you've read them, right? You can replicate them, right?
Yeah, hopefully. So let's go back to opioid addiction. Payam, what are your thoughts on this? I haven't had a chance to.
Yeah, I mean, I confess I've never thought about it. I have been addicted to nicotine. I smoked for several years. I assume it's like a much more intense version of that. And it was probably one of the hardest things I had to do to get over it. But I don't have anything intelligent to say. I have no idea what to do about it. It's really hard. Like addiction is really hard to get over.
Yeah, I mean, I'm still addicted to food. I haven't transitioned off of that. But I guess the question I'm posing is more kind of from a computational or data science perspective. So let me give you a little bit of my kind of background. So this healthcare startup I've sort of been on and off with has gotten into kind of the opioid area as a way of trying to kind of circumvent some of the regulatory problems with bringing other things to market. So if they do it in sort of the opioid market, the others paths become simpler. But in general, I'm really surprised at kind of how little people in medicine understand data and how uninquisitive they can be. So my first introduction to this was when I was looking at asthma issues. And my takeaway from looking at the studies was, I don't know, somewhere between 1.25% of asthma patients were either misdiagnosed, on the wrong medication, or on the wrong dosage. So to me, that seems like a comparatively high number. And the existing standards of practice are essentially make a diagnosis, based on the diagnosis, recommend a high drug treatment level, and sort of only slowly back off from that. So you can imagine an alternative world in which you have a lot more information, you've got a lot more, you've got historical information, you've got sort of real-time information, Fitbit type stuff, where you could start to think about asking the question, okay, how could I answer these questions better? Is the individual correctly diagnosed? Are they on the right dosage? Or are they on the right medicine? And this kind of shows up in opioids. So a little bit of the history there is that the at least in the US, the way the problem kind of got started is there was a shift towards evaluating physicians based on how happy the customer was. So one of the things that led to was physicians over prescribing certain types of drugs, opioids prominent among them. So that in turn kind of, I mean, the use was sort of increasing from an institutional perspective. And then on top of that, you had this, big influx of people writing prescriptions, and hence lots of the drug out there running around. But you'd think that people would have kind of a good understanding of what the triggers are of addiction, but the answer doesn't seem to be so.
But what do you think about, like, I mean, I would even question, I don't know anything about this topic. I'm just like, the first thing that comes to mind is these super highly addictive drugs should never have even gone to the market. It's not on people to be worried about getting addicted and be like self-disciplined enough to stop it. I think having these things in the market should have been stopped. They should not have been there, except for very, very like hard cases where people are in like excruciating pain and there's nothing else to do about it. I think that might be like, I don't know if it's a conspiracy theory kind of idea, but maybe the pharmacologists should not have allowed it, or they should not have produced these things. There should have been regulations stopping it, not like limiting it.
Well, I mean, certainly think ex post, that's correct.
But it's very, very hard to know that beforehand.
But don't you know how addictive these things are? Like, they must have known before releasing it.
Not really, no. I mean, I've been kind of summarizing some of the clinical evidence. I mean, they've been able to identify certain factors that are associated with higher opioid use. But, it's really pretty crude. So, if you have a previous substance order, yeah, okay, so you have a higher likelihood of it. There seems to be some genetic basis, at least among kids, for it. But, I mean, so if you had this problem and you were trying to do something about it, what would you do?
I have a very complicated answer, but
yeah.
So let's go through my paper briefly, because I'd like to refer to some of that in order to answer your question. So my suggestion is we take a brief look at the paper that I'm working on. We use some of the concepts from that, and then I draw those concepts together to try and respond to you. Okay, cool. All right, let's try that.
You guys do way too many things in a course of the week: writing a paper, figuring out liquidity, and fixing the opioid crisis, and dealing with shoulder pain and COVID. Like, I don't know how you guys manage.
Okay, so Pam, have a read, and if anything glares out at you as being bogus, just let me know.
I mean, there are things I don't know in this, but I assume you'll explain. I don't know what endosymbiotic system is, but.
Okay, endosymbiosis is the idea of eukaryotic cells. Do you know what a eukaryotic cell is versus a basic cell? So eukaryotic cells, there were other cells that invaded cells and took up residence inside other cells. So your mitochondria has a completely different genetic heritage than your main cell. So if you go down to the cellular scale and you say, this is my cell, this is my DNA, you're wrong. because the DNA that is human DNA only builds the shell, and inside that shell there are lots of other cells that have nothing to do with human DNA and don't come from human DNA, that live inside our cells and are as much us as our cells are. So this whole idea of genetic predisposition, you have to say which cellular organelle are you talking about, right? Because they all have their own genetics, they all have their own genetic history, and they all respond to the environment in different ways. So Linda Margoles's work is really profound, philosophically speaking, because she's really talking about, think of two trees growing up next to each other, right? If there was no tree next to them, like if you go to Stanley Park, there's this, near the golf course, there's this tree in the middle of an empty field. And it's never had a tree grow near it. And so it has this ability to grow completely by itself, and it forms a perfect Christmas tree shape. It's literally a triangular tree. But when two trees grow next to one another, they crash into each other, right? They have to learn how to live with one another, and they basically have to learn to get along in this not very good way. One tree might try and kill the other tree, or if you think about this as animals, one group of animals might try and kill all the competition, or they just learn to get along. So this is all kind of built into this uber idea of endosymbiosis. So a topic for another time, but very, very interesting. Carry on. This goes on for a bit. I can send you the paper and you can read it offline if you like.
Sure. No, I think I get the gist of it, but I think, yeah, it requires an explanation from you, I think.
And there's some pseudo math in here that I've been working on, blah, blah, blah. It goes on and on. I'll send you a link. But basically, I can explain it in a different way. I'll just explain it visually. So I have this. Okay. So this is the classic encoder-decoder model of an autoencoder, variational autoencoder, or a GAN.
I like the picture.
They're all the same. So basically, you have a large field of information coming in. It goes through a set of layers, and then ultimately those layers produce a latent representation, which is this. And then those layers are passed to a decoder, which takes that latent representation and decodes it back into the original. You then compare the input to the output by some distance function, and that forms your credit assignment. And then basically, once you've assigned a credit, you can then back propagate, and these layers can learn how better to achieve the output and so on. So this is the classic autoencoder structure, no argument, no question. And what I'd like to talk about, and I'll just go. So if we look at, I'm just going to do a bit of fiddling around here because I've got many layers turned on. Okay, so let's look at this situation. Oops, I got that wrong. Hang on.
What is this software? I've never seen it before. Rhino?
Yeah.
What is it for? Is it like for graphics
3D
design?
nerves. It's a non-uniform rational B-spline 3D modeling tool.
Okay, cool. It
It's
looks
old.
expensive.
It's not actually. It's about $1,000, I think. But then once you bought it, then it's yours. Okay, so this is a different model. So here's the basic idea. You build a generator using, so you set up an autoencoder or a GAN or a variational autoencoder. You do that, right? And then you run this training loop where you encode into latent space, you decode, you then assign credit to backpropagate, and you run this until neither system is learning anything anymore, right? Until basically the GAN is as good as it's going to get, right? To some limit. Okay. Then what you do is you hold the weights of the generator constant. So the generator isn't learning anymore. Okay, so now it's fixed. And now what we can do is we can pair different credit assignments with different encoders, right? So I want you to encode for warmth. I want you to encode for threats. I want you to encode for safe navigation path. So you can set up these different attention heads, which are these different encoders. So each encoder and decoder independently is an attention head in my argument. And so you can pair these untrained encoders with a credit assignment mechanism, and you can train multiple different encoders to drive the decoder. Okay, and this is really interesting because this gets right back to the opioid question. So what I'm saying is as follows, in that by building a system in this way, you can essentially have different attention heads take over the generator and essentially drive its behavior based on the credit assignment function of that particular attention head, right? So you get a huge amount of credit assignment when you take opium, I guess, right? So you get this huge reward, and you have an attention head that is formed by that reward that then comes in, and it basically you have a set of behaviors that are independent from other sets of behaviors that drive your behavior in the opioid addiction, right? So this one over here is opium. It's an opium attention head, right? So if you see opium, or if you hear the word opium, or if you see something that reminds you of opium, this attention head is going to light up like a Christmas tree and take over the latent space, which will drive your body to take the drug or whatever it is, right? Your rational attention head is not the same as this one, and it's being suppressed by the opium attention head, and your rational behavior is essentially repressed because this attention head has so much power that it can essentially shut down all the other attention heads and take over control of your body. Does that make any sense?
Yeah.
So we are multi-conscious in that we have all these different attention heads that can drive our body, if you will, in this way. And we can basically, there's something, I don't want to get into that, it's too complicated, but basically one of them takes over. One of them is running the show at any given point in time, let's say, right? So if I'm driving a car, then my car driving attention head is manipulating, is driving my body through this latent representation, and I'm driving the car. And then I receive a phone call, and that's where I get into trouble, because if I take the phone call, my attention head that's driving the car is suppressed, and I stop driving the car well, and I'm talking on the phone. So there's this kind of time sharing problem with our attention between these different attention heads. And when we talk about opium addiction, where my mind goes in this argument is here, which is you need to essentially suppress the opium attention head. You need to remove the cues that fire the attention head, either physically remove the access to opium, access to the tools of opium. I don't know what the triggers are, but basically you need to try and cut off access to stimuli that cause this attention head to light up, in one sense. The other thing you could do is you could trigger this attention head and then apply a negative reward to it to try and suppress its kind of lighting up like a Christmas tree, and essentially try and create another attention head that is negative, that is essentially fighting with the positive attention head or something like that. I don't know quite how the mechanics work, but as a kind of scientific, rational strategy to deal with opium addiction, this is how I would respond. I'll stop there. Does that make any sense, Rob?
Certainly does to me. Kind of the question, architectural question that comes to mind then is, so what's the process for determining which one of those green pyramids we pay attention to?
This is an abstract model, so I don't know, but
there would seem to be something sitting on top of that.
a control mechanism of some kind?
Yeah, yeah.
We would like to think so.
I mean,
So
don't we have the ability in our minds to kind of, you know, at least usually figure on what we're going to focus on?
Okay, so we have a prediction engine that says if I go into an opium den, then all of the cues that will fire up my opium addiction attention head will trigger, and my opium, and I will get carried away and essentially take more opium than I should. I don't know, I'm making this up, but what I'm trying to get at is we can mechanically remove stimuli. So we can remove the equipment, we can make it hard to get opium, we can make it very inconvenient, we're not solving the problem, because if you are handed a bunch of opium, you will consume it. So it's not solving the addiction problem, we're just essentially trying to remove the stimuli that would lead you to that negative outcome. And that we can do as a society and as an individual. But beyond that, I'm not sure.
So this is maybe an alternative view. So there's a series of, I guess, famous experiments about rats in a rat park. I don't know if you've heard of that, related to addiction. So you can read, I don't know, I just Googled this one. I don't know if this is the best source, but it refers to the experiments that were done in the 70s. Basically, they had a bunch of rats, they got them addicted to something, heroin or something. And then some of the rats so they never left. So the source of the heroin or whatever it was they used was always there. They never removed it, but then they had two groups. One group of rats had access to a rat park where they could play with other rats and, you know, mate and do all sorts of other things. The other ones were sort of isolated. And it turned out the ones that had access to the rat park, or they could have other things to be happy about, they would abandon, even after being addicted, they would abandon the source of the heroin and they survived, while the other ones basically kept going to heroin until they died. So I guess the point being that part of like people who get addicted is that their lives in other ways is broken, and that's one reason so it's not just that the thing that if you take away all the source, that, I mean, that will work. If there's nothing to be consumed, to be addicted on, then that will work. But another solution could be like trying to more fundamentally solve people's problems, life problems, and that would also help. So I suspect a lot of the people who are part of this opium crisis, I guess that's an empirical question, are probably poor, they're not having great lives, and they're like suffering in other ways. But I think that's something you would want to look at in the data, I guess, before proposing solutions.
I'm not proposing this as a solution. I'm just proposing this is my understanding. But just to be clear.
No, that was just general.
Yeah.
It's not about.
Yeah, no, but I agree. And I think that, so to try and explain what you just said in this model, let's try for fun. So what you're saying is that this attention head does exist and is there, but it's not novel anymore. And negative consequences of that are starting to essentially offset the initial euphoria. And then these other attention heads are being fired up through social interaction and new, constantly new and interesting things. And they actually are winning the war in that they are actually more rewarding for the individual than going back into your hole and taking hope. Once again, I'm making judgments I have no right to make because I have no priors. But yeah, so I completely agree. And I think that this idea of having a rich set of potential attention heads that you could develop. I don't think they're developed. I think some attention heads are genetic, and I think many are not. They're just essentially manufactured on the fly. Like we became interested in computers, but before computers existed, we didn't have computers, so we weren't interested in it. So we became interested in things that didn't exist in history all the time. So I would argue that these attention heads can essentially be manufactured from nothing, that you can basically, like when we now have a huge amount of attention being paid to COVID, which didn't exist in the past. And so we've got this whole set of practices and all these different ways, all these different taboos and all this different structure around COVID that's developed through priors, from priors of other experiences. I'm not saying it's novel, but we assembled this new attention head. And now when we say COVID, we kind of load up this, oh, okay, put on my mask and, all this other stuff. And when we say global warming, we rush through our recycle bins and put in glass bottles and other things. So we can develop these new attention heads as a society and as individuals over time. And these emerging attention heads, I think what Pi is suggesting, which I really like, are essentially a cure, in that the way to forget bad things is to have more interesting new things to think about, not to try and avoid the past, but to have a more interesting and curious future. So,
well, what role now would be played by the latent representation from that perspective? I mean, is that something that's kind of purely passive, or is that something that you sort of intervene and try and tweak?
well, let's talk about that. That's very interesting. So that's an excellent question. Okay. So that's this picture up here. So let me see if I can get this right. Sorry. Sorry. Okay, so in this situation, it's exactly the same, where we've trained again all the way to the end using some credit assignment thing so that the input matches the output. We've generated some latent representation here. And this is the same latent representation here and here. But what we've done is we've injected this kind of translator. So in category theory, there's something called a monad, and this is basically a monad where you're going from some category back to the same category, but you're injecting some new bias into that, right? So we would encode the information, we would then modify the information, either with perhaps with medical drugs or with electrical stimulation or with experience, I don't know. But you basically would be able to essentially insert a translator that would, or a bias mechanic that would take this latent representation and then warp it or change it in some way to change your behavior. So this would be, I guess you could think of it as medical intervention, right? So behavioral intervention would occur over here somewhere where you change the stimulus, right? But if you're exposing the client or the patient to the stimulus and you want to change the effect, then essentially you have to take the latent representation and modify it in some way in order to modify the response to the stimulus. Don't know if that helps.
I mean, this is kind of an advertising model, if you will.
Advertising model, explain.
Well, I mean, this is what advertising does. So we see an image and it creates this new filter that we try and take that image and map it into something that's got some sort of more permanent resonance with us.
Sure. Yes. Yes. Sure. Yeah. So in that sense, yes, it is a behavior modifying. It's changing the bias in the stimulus. And if we go back to my paper very briefly, I'll share what I mean by that. This one. So let me explain this for a moment. So what I'm trying to get at here is that the valuation that we apply to something, right? So we are observing some phenomenon, okay? And the value that we apply to that is some function which allows us to compare that to our priors and to other coexistent. Okay, so I'll explain this in terms of stocks. Okay, so what I'm trying to say here is the value of a stock for a given observer, right? So if I'm playing in the stock market and my name is David, and I am observing the stock market and I'm interested in Apple stock, and I'm trying to say, do I think Apple's going to go up or down? Okay, so the valuation that I come up with has 4 contributors. It has the value of all the other stocks in the previous time step, okay, and that could be if it upholds the Markov property, that could just be a latent value, right? So basically I encode history into some latent vector, and that's this, right? That's the kind of history, my current take on history for each of the other stocks, including this one, because why would I buy Apple when I could buy Amazon? Because it's a much better, whatever, you know. So you want to compare it to others. You have exogenous information. So this is public information that's available to everybody. Apple's announced a new Bishmigli, whatever it is, and everyone knows that, and you know that everyone knows that. You then have hidden information, which is not known to anyone, right? Which is not observable, but it's kind of unobservable hidden information. And then finally, you have private information, which is your personal bias or your personal priors associated with that stock. Oh, I don't like Apple. I bought their phone and it didn't work, right? So there are these four kind of contributing factors to your decision-making process, right? And you can't really use the hidden information, but you might be able to infer it using machine learning, right? So that's a problem. So to go back to the question that we were asking, so I'll go back to the other picture here. Actually, I kind of got lost in the thread there. Just one moment. Why is it doing that? Sorry, it's doing something strange. This one. So, so where were we? Sorry, what was the question I was trying to answer?
Hidden information and prior information. And
right. So if we go back to the multi-attention head model, each of us is a separate attention head, right? We have our own personal experience. We have our own priors. We are exposed to the same information. So the public information comes in here, right? So when we have public information, that's there. We have our priors, which are encoded in the layers, right? So the weights in the layers themselves are the personal priors of this attention head, right? So that's its personal biases, okay? And then we can also essentially generate we can generate latent representations for the other stocks by combining public information with our priors, which is our private information. So if we combine those two, we then come up with some valuation. And that creates preference selection in the market, and that creates the buy and sell stuff in the market. I think I dropped the original question that I was trying to answer, because now I'm talking about the paper and I was trying to answer a question. Pine, what are your thoughts on what I'm saying? Does it make sense?
Kind of at a high level. It's just a lot of details. I think I need time to process everything. You connected everything we have talked in the past 6 months into one story. So I need I think I'll need time to
okay,
process.
well, I'll share the paper with you right now, and I genuinely be curious to your comments. So we were talking about this feature here, which is this behavior modification kind of idea. So other attention heads might be controlling this. I guess that's what I'm saying. So let me try and do that very quickly.
Controlling the gray box?
Yes. So this gets into the Jeff Dean picture, which I think is truly profound. The article you sent me was amazing, Pine. Thank you so much for that. That was really, really interesting. I'll just bring it up again because I just think it's extraordinary. So let me do that next.
You're talking about the pathways?
Yes, I'm talking about the pathways. If you can pull it up faster than me, feel free to do so. I'm looking for it. Oh no, I'm not finding it. Shoot. Okay, so I'm gonna have to go there. You sent that to me in Slack, right?
Yeah, just send it again.
In Slack?
No, in Zoom.
In Zoom, sorry. Okay, great. Okay, that's fine. So let's look at this picture together. Are you, oh, you're seeing my whole screen. Hang on, that's not useful. One second. So the video, and then I go here. No, that's the whole bloody screen. Anyway, you can watch this offline yourselves, but what I'm trying to get at here, let's just pause this for a moment. Yeah, so these different nodes here in this graph, we can consider attention heads in my understanding. They're separate models that have their own priors and their own training. And these pathway, these linkages between these different, I'll see if I can make it a bit bigger, not really. These pathways are essentially latent spaces, right? So the connection, so in the same way that we can train, we can hold the this particular module's constant, we can train multiple drivers of this module to use the its latent space effectively, right? So this can utilize it by building a path from here to here. This can utilize it. So the example I use is locomotion. So if I'm trying to move through a virtual world, if I'm trying to move around in a 3D world, I have a bunch of different ways I can do it. I can use a gamepad, I can use a mouse and keyboard, I can use a Kinect, I can use all these different motifs to control how I'm moving in space. So this node up here is how I actually navigate in space, but the input to that might be coming from a joystick or a keyboard or a mouse or some other device. And these are different mappings into this particular attention head. So if we think about this in terms of pathways, then this attention head here, this one, can affect this pathway, right? So rather than this pathway going directly from here to here, it might pass through this and be modified in a subtle way before it arrives here. So we could essentially have attention heads arranged in some sort of a graph, and they have the various different latent representations that share information between those different attention heads. And now we're building brains. And this gets right back to the David Deutsch article that Payam posted. So this to me is the closest I've ever seen we've come to actual AGI. I know it's not true full-blown AGI, but this idea of having an unsupervised network of attention heads that essentially can build latent representations and pass those latent representations between these different attention heads over time in a completely unsupervised way based solely on priors, I think is a very interesting idea.
So in that representation, how is the selected path determined?
Once again, it's okay. So we have to talk about goose democracy. So bear with me here. All right. So you've got a wedge of geese. Okay. So there's a goose at the front, and it's steering the whole wedge, right? So if it sees an eagle, it'll turn to the left to stay away from the eagle. If it doesn't see it and it sees what it thinks is good, you know, pasture to feed on, then it will move to the right. But as in taking control, it starts to deplete, right? It starts getting tired. It's going to fight the wind, and it's, you know, it's hard work, and it's going to think and steer and all this other stuff. And so it kind of wears out after a while, and then that goose gets tired and it falls to the back, and then another goose moves to the front and they take over. And now they're steering and they're depleting and they're having control for a while. And by doing this, and there's another effect, which I think is really interesting, which is when one of the geese falls out of the V, like when one of the geese kind of starts falling away or doesn't want to follow, all the other geese start honking. Okay, so you're essentially, all the other geese have noticed that you're not kind of following along, and they're complaining that you should, and you have to, it makes it harder for you to kind of break out of the V. And that way, this V persists for a long period of time, but the controller is constantly being switched, because whatever is in control has control for a while, but then depletes and switches to another attention head, if you will. So the attention heads are essentially in this kind of goose democracy where one of them has control for a while, but then it gets tired and falls away, and then another one comes to the fore and it dominates for a while. And that's really the mechanic that's used to switch between these different activities that the agent is performing. Does that make sense, Pat? I've lost you.
Yeah, kind of. Still processing. But I guess as far as I know, there is no proposal, or I haven't seen any model that actually does that today. Like the Google Pathways, I mean, all it does is just performs tasks. Like we're talking about simple tasks like, I don't know, classification, whatever, and you just pick. I mean, that was their way of stringing together all these models they developed separately to be able to utilize them. Do they like unsupervised decision of which nodes models to query and how to string together? As far as I know, is beyond the state of the art, at least as far as I know about what's been developed. If you have any examples of people having done it, that would be cool. I don't know how you would go about, I mean, like, even for humans, we don't understand, right? Like you're just jumping from one thing to another in your brain and you don't have full control over it. I don't think we understand how we do it.
Well, yeah. Some parallels with bicycle racing, certainly.
What's that, sorry?
Oh, no, yeah, you've got the sort of evolving leadership.
Yes.
People.
Yeah, same idea, exactly the same idea. Like one person's out in front and they're setting the pace, right? They're setting, you know, the style and everything because they're winning. So if he takes the high path because that's more energy efficient than everyone else, well, the Baldwin effect will kick in and everyone will copy him. And then he'll get tired and fall back, and then somebody else. That's really the model that I had in mind for managing which attention head is in control at any given layer.
I mean, what makes it complicated, like if you think of, let's say, human beings as a machine, it sort of makes sense. Like I said, like you're going back to your soup analogy, like it's a soup of chemicals, depending on what's coming in, what you ate, how much you slept, what you just saw, they get mixed up and one of the attention heads takes over for a while and then you get tired, it switches. So if you look at it that way, it makes sense. But if you want to think of humans as an agent that decides between these attention heads, I don't think we have any evidence that's the case, or how you would actually do it, implement it.
I don't think you can consciously decide. There you go. I think that what we call our conscious mind is just one attention head among many.
So then that, I guess, you're going to get into trouble with people who believe in free will and all that. Like the whole agent-based model sort of implies that there is an agent making decisions, not just a bunch of things interacting and you get an output.
So this is the work of Kahneman, and this is system 1 and system 2. Yeah. So the idea is that system 2 is the dominant system, it's the grasping, controlling system, and it has the ability to manipulate all the other attention heads and tell them what to do. And the opioid crisis tells us that this is not the case, because if it could do that, we wouldn't have an opioid crisis. So, yeah. I mean, does an opium addict have free will? I don't think they do.
I would so far and argue that humans don't have free will, but opium addicts is a subset of humans, I assume, most of the time.
Yeah. So, I mean, in terms of, well, if you define, it depends how you define free will. Rational behavior, let's call it rational behavior, right? So, explainable behavior.
Isn't it pretty rational? I guess if you take some substance and you feel good, it sounds perfectly rational.
Well, it's rational to one of the attention heads.
That's what I'm saying. Yeah, it's not that simple. Yeah.
No. I never said it was simple. No, I'm not claiming.
Yeah, I mean, they're economic models of rational addiction. Yes.
Yeah. So, but very much on point. The David Deutsch discussion is very much on point, and I'm very, very interested in thinking about it from his perspective. And I will read the book. So thank you, Pam. Yeah, so that's the paper I'm kind of thinking about trying to put out there. So the idea is to try and see if we can basically emulate some of the behavior I've been talking about, where you have the data set that we have, right? So Rob's given us this liquidity data set, and it's a three-dimensional cube where you have a time series in one dimension, you have different choices, different stocks in another dimension. And in the third dimension, you have these different metrics, these different essentially stimuli associated with each one of those stocks. And we're trying to make a rational choice as to what to do at any given time. And I'm trying to use this attention head model to describe that, that's all.
You know, something you could potentially do with that data is to investigate sort of objective measures of the information available.
So the amount of public information available?
Yeah, correct.
Yeah,
What do you
so
mean
what are
by
the-
objective measures?
Well, okay, so, you know, they would be things like news articles, Twitter content.
Yeah,
I mean, things that would sort of, if you have some sort of, if you're a trader and you have some sort of optimization algorithms that's sitting on top of your different attention heads, you know, it might gravitate towards the stuff that, you know, is the loudest.
mm-hmm. So basically there's this kind of power grab in the goose democracy, in the bicycle race, whatever you want to call it. And there has to be a winner, and whoever kind of makes it to the front and can hold that position for long enough is the decision maker. And so that will ultimately guide your choice as to whether you buy or sell.
Okay, so, but yeah, suppose that's true. Now, what does it mean?
So
It means you're going to be focused on that particular attention head.
that's right.
You're more likely to do something, I guess, based on that attention head.
So one of the interesting things that we could do is we could try and look at trading behavior and classify, try and come up with different behavioral patterns of different attention heads in the model, and try and actually characterize the buying and selling logic just by comparing the behaviors of individual agents over time to, and this is highly related to liquidity. So we have these kind of, so let's for now say that the objective information is encoded in the model, right? So in your priors. So your objectivity is your experience. No, actually, let's say that it's the metrics. So we have these standardized metrics, right? So we just take the past, we take public information from the past, we apply some biases to it, we crunch it through some algorithm, and we get some measure. And that's exactly what the channels of information in the liquidity data set, to my mind at least, represent, right? They represent different.
Does that mean in the latent space?
No, well, they are a form of latent space, yes. So you have a latent space with as many values as there are channels, right? So what is the last, trading price for Apple? That's a datum, and that datum exists in combination with other values in some latent space that's being pushed into a generator that's generating some activity, right? So the other side of the kind of the structure, and I'll just share this with you very briefly as well, just to try and finish the description. So that's that. Is the idea of having multiple generators. And I don't have a lot of thinking on this yet. I haven't really sorted this idea out. I'm just curious what you guys think. So let me share my screen. Let's run. All right, and I'm going to share my screen. Okay. So in this situation, we hold the weights of the encoder constant, right? And now what we're doing is, so in this scenario, this would be public information, right? So now we have a set of attention heads that have access to the same information, which is this latent representation, right? So we would, so this encoder here has already happened, right? And what we have is our data set. So our data set is here, and it is a latent representation because we've essentially encoded it's encoded the experiences of stock prices in the past and today's trading as some latent representation here. And we're feeding that latent representation into a set of generators that are generating different counterfactuals, right? They're generating different possible outcomes. And now the goose democracy is between these guys, right? Which one of these is generating the most compelling version of the future that I like? And I'll choose this one, right? So in this one, it goes up, and this one, it goes down. And in this one, it stays the same. And at this one, and this one, we're not sure, right? So we have these 4 different possibilities. Based on the priors encoded in each of these attention heads, this one wins, and it says it's going to go up. And so we act on that that insight, right? That attention head coming to the fore. So that's the way of thinking about it that I grew up with. Does this make sense? Like, is this worth pursuing, or should I go back to the drawing board and come up with better analogies? I'm not sure.
Yeah, I think I need to understand it more.
Okay. Let me share the link with you right now. I'll do that as we speak.
Yeah, so I mean, in a trading world, you could have 3 alternatives. You could, increase your position, decrease it, or do nothing.
Yeah. Exactly.
But I guess I'm like, I don't know. I would like to know, I guess, a little bit more of the details of how what are the architecture? How are you training it? I mean, you mentioned a lot of things like credit assignment. There is no credit in the autoencoder, right? Like, how do you bringing in a credit? And also, I mean, how is this? I guess, what are you getting from using encoders as opposed to, I mean, this is like a function, right? You have some inputs and you want to decide between 3 things. Like, why do you want to bring in all these like huge machinery of attention heads? I mean, I guess they're big words that I guess I want to know what goes inside it and how is it different from a regression model, because you can also call the parameters in your regression model attention heads and do all these things.
And you could. I'm agreeing with you that you could. Yes, your insights are spot on. And this is a weak theory here, so it could easily be punctured. So that's fine.
Yeah, but maybe we can take a simple example and just like go through all the details as opposed to like the other way around, which like you're sort of giving the big picture overview, but I don't know how these things fit together. Like, how would you train such a thing? How would you use it? What do you need? Yeah, those things, I guess I'm not clear on yet. I guess I'll read the paper, but maybe it's there, but I don't know.
The paper is very much incomplete time, so take from it what you will, or nothing at all. But once again, I don't have your email address, so I'll just share it with you, and then you can make a request, and I'll grant you.
Oh, sure. But I mean, I think it's not a criticism. It's just I think we have very different styles. Like, I like to start with something I fully understand, simple, get into all the details, and then expand out. You go from the completely opposite way. You go to the ultimate thing, and then you try to work your way back. So like, it's just a difference of style. I just like I struggle understanding things unless I know exactly how you would go about doing it.
Yeah, and this is part why I really enjoy talking to you guys.
And that's so differently, yeah. So I sent you a link, and you click on that, and then I will grant you access happily. Rob already has access. So,
yeah.
And I pick away at this, so if you're curious, you can check in every couple of days, or I can post an update saying I've made some changes. But I'd love you guys to collaborate on this with me. That would be fantastic.
Yeah, I mean, it's so different from kind of how people in my area would approach the problem, but it's interesting.
Well, if you think we could build a bridge to their understanding, then that would be great, because I think it would be a very interesting way of introducing machine learning concepts into economics. And into a
Yeah, I
bunch of
don't
other
think
things.
I don't think you even need to like convince anybody. All you need to do is get results that otherwise you can't get by simpler means. All you need is like one instance of that, and I think you have people's attention. No pun intended.
Sure. Okay. I will grant you attention. Sorry, I will grant you sharing ability. Yeah. So yeah, so we're at time, Jim. So we can carry on if you like, or we can roll on. So next week, why don't we have a chew on the paper, and we'll also cover Deutsch's arguments and see if we can use his arguments to see if we can create some sort of tension between his view and the view that that's emerging, and see if they actually are compatible or incompatible. I would argue they're compatible, but let's see.
Yeah, I mean, his ideas are very extreme. Like it's kind of, that's why I found it interesting. Like he's almost arguing against Bayesianism and against like deep learning the way it is. I mean, not that they're not useful, but that they're not going to get us to like an artificial general intelligence. That's not how humans do it. So I'm curious, like, just read it. Don't take my word for it. But
I did read it, and I think that there's some interesting points. But I think it's valid that Rob has a chance to chew on it as well. So, okay. Rob, do you have the link, or
this is the Pathways one?
No, the David Deutsch one. It's in. You might want to post the link again. I can
no, I don't have that one.
1 second. Yeah, I can post it here.
How was your week, by the way, Pine? We've been doing all the talking and you've been doing all the listening. What's new with you?
Not too much, just a slow week. Yeah, my original project I was working on is not clear whether it's going to be useful to the organization a little bit, because that couple of projects seem to be ending like earlier. Like we were hoping to extend it, but they weren't. So now I'm sort of debating whether it's worth doing. Yeah, it was a little bit of a depressing week. Also, one of my coworkers went to Facebook, like one of the people I really enjoyed working with. So that's kind of depressing. But they doubled his salary, so I can't blame him.
Lord.
Yeah, keep those contacts.
Yeah. Apparently, like they actually asked him like not to try to bring people from your current organization, because apparently people have tried and they get into legal trouble because of all the things that they have signed that you're not supposed to poach people. But no, I have no interest to work in a place like Facebook, but I mean, I can't argue with like double the salary. You know, every year you work is like 2 years of working. So it's kind of hard to discourage people from doing it.
Understood. All right. Well, I'm actually looking for some work myself. So if you think if there's something that might be a fit for me, let me know and I'll have a look. So very cool. All right, gents. So what do we call it there? I will keep chipping away at the paper. I might. So do you have Slack up and running? Doesn't sound like you're getting Slack notifications, Rob. So that might not be a good channel. Yeah, should we set up a Discord or something, or what would be a good kind of chat channel for us? I'm very happy to use.
For some reason, yeah, it seems to sort of periodically stop telling me stuff.
Yeah. Okay.
Just use email, I guess, if that's easier.
Sure, I'll just send you an email. I'll try. Once again, I guess I could find your email from the share link, so I'll just respond to that. So
we have corresponded before, no? You've sent me stuff.
I find it really hard to find your, and I know you have different emails for different things, right? So
no, I only have one email I've used. It's just P Musavi, my last name at Gmail. So it's simple.
P Musavi. Okay. Yeah. Simple enough. All right. Great. Okay, gents, great to chat, and we'll catch up next time. Thanks. I didn't have a chance to talk to Rose this week. I will try and follow up with her, but take care.
Okay, take care, everybody.
Bye.